Okay, I guess I might have been wrong. A few months back, a lot of media sources, including I guess myself, basically assumed that this was the end of Voyager 1. And this was because of the unusual data coming from the Voyager 1, where it was basically sending a bunch of zeros, implying that important hardware must have failed. And though back then it wasn't clear what's actually happening here, most of us kind of assumed that this was probably the end of Voyager 1, and it was maybe the time to retire the mission, which has now functioned for literally 47 years. To which a lot of NASA engineers, especially the ones that actually worked on this mission 40 to 50 years ago, kind of said, yeah, hold my beer, let's actually fix this thing. And fix it they did. It only took approximately 6 months to bring everything back to normal and to make Voyager 1 function once again. And that by itself is absolutely mind-blowing. Because you have to remember, this mission is really far away. NASA actually released this image to kind of show us how far away this is, but this doesn't really show us much because it's a logarithmic picture, and it's hard to judge distances here. Instead, you can actually use one of the NASA's websites to basically discover everything about this mission, including the fact that it's about 163 astronomical units away from the Sun, or about 15.2 billion miles. Or if you were to try to visualize this, there's even a 3D map that allows you to see where this object is located compared to everything else. Which of course means that it takes a while to communicate with Voyager 1, because the light traveling here takes approximately 22.5 hours. Yet despite of this, after roughly around 6 months, we basically got this tweet from NASA itself. We're back, baby. Which is both unexpected and super exciting. With NASA also releasing this image of all of the engineers and pretty much everyone involved in this mission, with several members actually being some of the original members behind the mission. Although a bit of a side note / fun fact. From what I've read about really important NASA missions, as a kind of a tradition, they actually tend to bring and eat a lot of peanuts, because apparently they're known as the Lucky Peanuts. Although in this case, it seems to have been replaced by Lucky Donuts. So times do change, I guess. But on a more serious note, I actually really wanted to discuss what the engineers discovered must have gone wrong, how they were able to fix this, and what's next for the mission for the next few years. And so, hello wonderful person, this is Anton. Let's discuss Voyager 1 once again, because it seems to be going and going and going. But on November of 2023, something must have happened here, because for some reason the spacecraft started to send very unusual data. Now we actually still have no idea what exactly happened, but it was pretty quickly worked out that it seemed to be a problem inside this right here. This is known as FDS, or Flight Data System, basically one of the computer systems on Voyager 1 and Voyager 2 responsible for packaging the science and engineering data before it's sent to Earth. And here this particular computer is made out of individual modules, or it's essentially a modular computer, that technically has a backup as well, but that backup computer has failed a while back, something you can learn more about in the video in the description, and so now one of the chips inside this FDS failed as well, and this resulted in unusual signals sent back to Earth, producing unusual gibberish. Now normally for Voyager 1, the way that it used to process everything was by essentially collecting all of the data from several instruments, and because there was a lot of data, some of this data used to be stored in various tape recorders, or basically memory modules, or I guess hard drives. And these digital tape recorders, or DTRs, that kind of look like this, would keep a lot of this data while it's being processed by FDS, which would then send it back to Earth using relatively high bit rates by 1970s standards. And so as the probe moved farther and farther away, and as the time passed by, and especially as the RTG or the nuclear power generator was producing less and less energy, at some point the memory modules had to be disabled. And a lot of instruments had to be disabled as well. And so instead of using memory, Voyager 1 now had to transfer everything almost directly, pretty much at all times. Or it basically had something like 48-second memory before everything had to be transferred to Earth. And that means that FDS became a really important part because it was constantly transmitting data, and it was basically the most important computer system currently operating on the probe. And so when that failure was discovered in one of the FDS modules, quite a lot of people kind of assumed that, okay, maybe it's time to call it quits. But by analyzing this further, NASA engineers worked out that only about 3% of FDS memory was corrupted, implying that this was probably because of a single chip. Now because this is a modular system, there's actually a way to reroute everything using software, thus ignoring that chip and making everything work on other chips. Which is precisely what they were able to do by dividing the code into individual sections and then storing them in various locations around FDS. And then of course the software magic began. The original Voyager probes had software written in Fortran 5. And that means that there are several commands in here that can directly change the code on the fly, basically changing everything inside the probes. And in computing there's that famous poke command, which in various high-level languages sets the memory to a specific byte at a specific address. Now apparently, in some of the older computers, this used to be used for cheating. You could basically change anything inside video games by using pokes as cheats. But in this case, the Voyager team used the poke command on FDS to relegate all of the important functions away from that failed chip on the FDS to other locations. And then, in April of 2024, they received some of the first working data. And within the next few months, they conducted additional minor repairs, resynchronizing timekeeping software, and confirming that all of the commands were executed correctly. And it looks like now they've announced that everything seems to be working just fine, with all of the instruments working and reporting correct data. Although here obviously only 4 instruments still work, mostly studying plasma waves, magnetic fields, and various energetic particles. But that's actually the important part, because for the past decade or so, this has now become an interstellar mission, or basically a mission studying the locations outside of the solar system. Even though Voyager 1 got to visit all of the gas giants, and it was technically a planetary mission at first, it's now left the heliosphere and is technically flying through the ISM or the interstellar medium. But the other instruments, such as the ultraviolet spectrometer or planetary radio instrument, have been shut down long ago because they're no longer required and because here the energy is no longer unlimited. This RTG has a half-life of about 87 years, so it's only providing about 70% of total power. And sometimes in the next decade, the power will no longer be high enough to pretty much run any of the instruments. And so by mid-2030s, this will probably be the official end. And interestingly, this also means that this probe will never really tell us about the Oort cloud, because it's only going to reach the edges of the Oort cloud, from where all of the comets usually come from, in approximately 250 years. And naturally, at that point, we're not going to be receiving any transmissions from any of the Voyager probes. Although hopefully by then, humanity still remembers about these missions, because this is literally the most iconic space mission ever, just because of how amazing it was and how much is discovered in these 47 years. And so once we lose contact with these probes, that's pretty much it. As a matter of fact, they're unlikely to approach any star system for millions and millions of years. The nearest approach is going to be 1.6 light years in approximately 40,000 years, with a star known as Gliese 445. This is a star that's about 17.6 light years away from us right now, and its trajectory is slightly toward us, so the Voyager is going to be intercepting it 40,000 years later. But then, for millions of years, it's just going to be a silent probe in the middle of interstellar medium somewhere in the Milky Way galaxy, carrying one of the strangest and coolest messages humanity has ever sent to outer space, the so-called Golden Record. Various sounds and images portraying diversity of life and various cultures on planet Earth, meant to be a kind of a time capsule for anyone out there that's going to maybe one day intercept this. And Carl Sagan even once compared this to basically sending a message in a bottle, but in this case to outer space. Maybe someone out there is actually going to catch it and possibly understand what it says, but yeah, the chance of that is extremely low. Mostly because detecting this probe in the middle of outer space is extremely challenging. But I think we'll talk more about the future of Voyager probes and what of course all of this means for humanity in some of the future videos, I guess when these missions actually fail. But until then, I'm actually more curious to find out if Voyager 1 or Voyager 2 probes will actually be making any more discoveries, scientific discoveries, just like they did a few years back. There was actually that one big study that discovered a tremendously large amount of hot charged particles, something scientists even refer to as the firewall, that you can learn more about in one of the videos in the description. And so until these future discoveries, that's pretty much it. Thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining a channel membership, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye. And of course, huge congratulations to the entire team from JPL.